focusing on vectors in today. So the thing that we need to know is that what is a vector? So a vector is a physical quantity that has both magnitude and direction. So when we talk about vectors, we talk about something like acceleration. We also talk about forces. We talk about displacement. Velocity and more, because we have many vectors. So remember, we also have the opposite of a vector, but I won't say it's the opposite actually. We have a scalar. Remember, a scalar is a physical quantity that has remember a scalar only has a magnitude but doesn't have a direction. So what we need to know is all about like we talk about both magnitude and direction. That's for vector. And then when we talk about scalar, we talk about only magnitude. So here, when we talk about magnitude, we talk about value. Let me write value here. I can say that's a value so that you can understand, guys. Okay, so on vectors, we apply many things. We apply field econometry. We apply Pythagoras. We apply conversions. We apply equations. Actually, we also apply some graphs. So if you can check, when we are dealing with vectors, remember we'll be focusing on magnitude and direction. So as guys, we're supposed to know when we talk about direction, we talk about what? So it's possible that we're gonna use up, down, up and down, up, down. Gonna use north. Let me just write compass. And then we can also use some above x-axis. We're gonna use below the x-axis. So sometimes we use something like north of east, or maybe south of west, or many things actually. So As guys, we're supposed to deal with vectors only on this topic. So we also use arrow to represent our forces or our vectors. So here, when this is our tail, and then here, this is our head. So the length of this arrow represent the magnitude of the vector. So what we supposed to know now. So the thing is, we'll be also dealing with Cartesian plane. Cartesian plane. So on Cartesian plane, we talk about something like this, so like a cross. So the thing is, it's like this. Has some values here. Let's say 1, 2, 3, 4. 1, 2, 3. So remember, it's all about like, remember on this side, we're gonna have -1, -2, -3, -1, -2, -3, -4. So this represents the y-axis, this is the x-axis, and then remember this is north, this is south, this is east, this is west. So as you can see, these is our directions, these represent directions. All these represent directions. So these values will be representing the magnitude. Okay, so let me show you by an example. So if you can try to check, okay, if you can try to check if we have a vector which is f1, let's say it's f1 to the west. I put this arrow to the left because our force is going to eastward or to the positive x-axis. So you can name this one as f1. So the f1 has the magnitude of 3 Newton. Okay, so let's also check another force that will be down south. So remember, as you can see, we can name this one F2. So this is going down the plane. So this is going down to the plane. So here we have F2. Our F2 is on the, remember, it's on the south direction. Remember, south direction has a negative magnitude. Remember, this is going to be -3 Newton. So also, if we can also have another arrow here, sorry, let me use another color. Okay, here's an arrow. It's on -1. Its name is F3. So F3 is equals to -1 Newton. This is supposed to be Newton. This is going into this direction, it's going to westward. So here we have no direction. Let's say we have a magnitude. Okay, take orange. So let's say we have also a positive magnitude, which is also F4. It's going up, which is going to be 4 Newton. So they say, oh, okay, I forget something. So here we have something that is called a resultant. We have something which is called resultant. What is resultant means? So resultant is the sum of the forces or vectors that are acting on the plane, and we also call a resultant as a reaction. It's where the reaction takes place. So in other way, so a resultant is the shortcut of the forces along from the beginning up to the end. So if you have forces going like this, and then it goes like this, then goes like this, and also goes like this, and then like this, and then like this, and then so here we if this is the beginning, let's say this is the start, and then this is the end. So our resultant force is from this point to this point. So it's from this point to this point here. So we call it this a resultant. So this is the shortcut where you were supposed to use, or maybe that's the sum of the forces that as displayed here. So we can also calculate the resultant force as saying the sum of the forces acting on the x-axis equals to, so we're going to focus on the x-axis. Our x-axis is this one. So let's check something here. So since we are checking this as our x-axis, so we have f1, it's going to this side, and then we also have f3. So we have f3, which also opposing the direction of f1. So we're gonna send 3 plus, remember, we take the magnitude here. So we say this is -1. So we're gonna have 3 minus 1. So which is going to be 2 Newton. So since it's positive, it's going to be east. I hope you guys understand. If you have like a negative answer, which means will be west. So since we got a positive one, it's going to be east. So okay, so let's check for our the sum of the forces acting on the y-axis. So let me try to write it here. The sum of the forces acting on the y-axis, we have F2. We have F2, sorry, and then plus F4. So let's check something. So our F2 has a magnitude of -3, and then we also have the magnitude of F4, which is 4 Newton. So the magnitude of, or the sum, or the sum of the forces acting on the y-axis is going to be 1 Newton. So when we want to find the resultant, we don't add these two, but if you can check, we have something which is called something like this. This is a right angle triangle. So we have the forces of horizontal, and we'll also have the forces of the y-axis. So we're supposed to find the reaction, so which our reaction is a resultant. So we're gonna use the Pythagoras since we don't have an angle here. So let me try to find a clean sheet. So we're gonna say the resultant square equals to the forces acting on the x-axis all square plus the forces acting on the y axis. Remember, we apply Python chorus. So we're gonna say our r square is going to be, let's try to go back and check our values that we got. So remember, on the x axis we got 2 Newton, and then on the y axis we got 1 Newton. Sorry. So we have 2 Newton square and then plus to 1 square. So we have 4, and then 1 to the power 2 is going to be 1, and then remember we have r square. So this is going to be r square equals to 5, and then we want the r, want the value of r, so we're supposed to eliminate the square. So it's going to be r equals to root of 5. So this is going to be Newton. So this is our resultant. I hope you guys understand. This is our resultant. So we also find we managed to find our direction using trigonometry. Remember, we applied, and if you can check, the thing that we use there, it's all there. Remember, we use the graph here, and then on the other side we use Pythagoras, and then now want to use the trigonometry to find the direction. So we're going to say then, remember I said we have a right angle triangle. So we have f of x here, we have y. So we can also find the angle of our, what we call, of our reaction. So we're gonna say theta is equals to tan into, remember, f of y over f of x. So this is going to be tan inverse of, remember, for f of y was 1 and then f of 2 was 2. Okay, so that was 0 0.5, and then gonna find the magnitude. If you can punch the calculator, you'll be able to find 26.57 degrees. So that's how you find the angle. When you find the angle, you check these two. Remember, these two were positive. The forces acting on the y axis was positive, and then those one acting on the x-axis was also positive. So if we go back to the Cartesian plane, remember, then the right side here, this right side was positive, it's positive actually, so it's positive. Also on the other side is positive. If you can check here and here, these two are positive, but this for y, they are all negative. Say that, definitely negative. So these two, fy, we got the positive one because which means it's aligned here, and then we got a positive, it's also aligned here. So we are going to say the angle that we got, which means it's here, so which is going to be 26 here 0.57, and which direction in north, is north of east. So that will be our direction. So you're supposed to know that, guys. So sometimes they say on the x direction, something like that. but it's still the same thing. So, okay, so let's try to check where we have the forces having angles. So let's say we're in the Cartesian plane, and then we have been given forces that has angles on them. Let me try to check. So let's say we have been given a Cartesian plane here. So we have a force here. Let's say this force is it's F1, which has the magnitude of 3. And then, so here, this force is on the 45 degrees. So, and then we also have another force on the other side, which is, let me write it here, which is also 30 degrees. But here, it has the magnitude of 4 Newton. And then you also have another one here. Let's say this one has the magnitude of, remember this, oh, this F2 supposed to be F2, and then F3 here. It has the magnitude of 7 Newton. Remember, it's negative because it's on the negative direction. And then we also have another force, which is also acting in this direction. So let's say we have been given 60, no, let's say 30 degrees, and it also have the magnitude of 8 Newton. Remember, it's 8 Newton. So let's check something here. Let's say we have been required to calculate so some of the forces acting on the x-axis is going to be, let's check. So remember, we have SOHCAHTOA. SOHCAHTOA is where we have a right angle triangle. If you can check here, we can also make a right angle triangle here. So we managed to make a right angle triangle. So we want this force 1x, one this force here, down here, one this force here, down here, and then we're gonna need an F1y for this force acting on the horizontal surface. Remember, this is a vertical surface and this for horizontal surface. So we'll be looking for horizontal and vertical components. So this is going to be components. Remember, we have F1 here, which has the magnitude of 3, and then we also have F1x, and then we also have F1y. So here we have 45 degrees. So we want to find the F1x and F1y. So we're going to say, remember, we're going to apply trig. So trig is very important. So let's check something here. So one, these two. So remember, we only have the value on the hypotenuse. So this is an adjacent, and then this is opposite side. So we're going to say our sine of 45 degrees is equals to, remember, our F1 is our hypotenuse, and then our F1y is our opposite. So we have F1y over F1. So one, the formula for F1, so it's going to be F1y going to be F1. Remember, we cross multiply F1 sine of 45 degrees, and then if we want to find the component of f1x. We are going to say f1x equals to f1 cos of 45 degrees. It's all about that. You're gonna also use this is still the same as when you say cos 45 degrees equals to f1x over f1. Remember, we said this is an adjacent, and then remember this we said this is opposite. So this is our hypotenuse. That's why it's like that. So we cross multiply. So this one cross multiply with the one which is under, which is beneath the cos 45. So it's going to be 41x equals to f1 cos of 45 degrees. So we have these two. We have these two values or these two components to look about. So everywhere there is an angle, you're supposed to do this. So you're supposed to check. We have something, maybe this is a rule. They say all students take care. So we use A as TC. So this is stand for all, and then this stand for student, and then this take, and then this care. So this is a rule, guys. This is a rule. It's a rule. You're supposed to know it. So here, this A in other way stand for all trig ratios are all positive. So here it's a if we have s, remember we have s which is for sine. Okay, let me see. This for sine, and then we have tan, which is t, and then we have cos, which is c. So if you can check, we have s, which is this one, we have t, which is this one, we have t, c, which is this one. So this also represent what's happening there. So if you can check here, I said here it's positive, and then here is positive, but here is negative, also here is negative. So that's why these things like are not equal on quadrant. So if you can check, we have something here, so where we have sine, tan, and cos positive, being positive, and then here only sine is positive, here only tan is positive, and here only cos is positive. It's all about that you're supposed to know. So we're gonna use that rule. Say if they say, remember when we use the angle, we use the angle which is on the x-axis. Remember, if you're supposed not to use the angle which is on the y-axis, but you're supposed to use the one on the x-axis. So we're gonna say some of the forces acting on the x-axis. We have this one. We're gonna say F1. F1 is 3 Newton, and then cos of 45 degrees, right? So we're not done about this one, all of the component acting on the horizontal. So we also have this one. This one also have an angle. Remember, I said we're supposed not to use this one, so we also supposed to get this one. Remember, this side is 90 degrees, and then also this side supposed to be 90 degrees. So if we have 30 degrees here, this is going to be 60 degrees here. So we are going to say, remember it's cos here, remember it's cos. I hope you guys you're understanding. Remember, here is cos, only cos is positive. We are going to say positive. Our F2 is 4 Newton cos of 60 degrees. The 60 degrees, that is on the x-axis, not on the y-axis, always. So we also have this. Remember, we're talking about the x-axis. Also, this is acting on the x-axis, so which is having a magnitude of -7 Newton. So we also have this one, this force here. So this force is acting in an angle, so which its own angle is 30 degrees. So we're going to apply the same thing. Remember, if we close this, we're gonna have an opposite here, which is going to be f of 4, which is y, and then f of 4, which is x. So we're gonna say, remember, we check, we're dealing with cos here. Remember, cos here is negative, so it's going to be negative 7. No, I'm sorry, it's negative 8 cos of 30 degrees. So we're gonna say, so 3 cos of 45, and then plus into 4 cos of 60 degrees, and then minus 7, and then minus 8 cos of 30 degrees. We are going to find the value of negative 9.807 Newton. So this is all about that, guys. So you're supposed to check like what's happening there. If you have an Cartesian plane, here you have been given a force in an angle. So you're supposed to check everything, and you're supposed to take the rule. The rule is very important. So you're gonna have this magnitude on the x-axis. So you can also try for the other one. So let's check for the y-axis. Remember, we have 3 for the f1, and then we have 4 for the f2. Also we have 8 for the f, is it 5 or is it 4? 4, yes, 4. So we're gonna say I'm sorry. So we're gonna say sum of the forces acting the y-axis is going to be, remember, 4, remember, was on the positive. Let me show you. Remember, f1 is on the positive. All of trig ratios are positive. So we're gonna say 4 sine of, remember, it's 45 degrees. And then remember, we're supposed to check for the other force. We have force 2. Which one? We're supposed to find the component of Fy. So we have 4, and then it's supposed to be sine. So remember, here sine is not positive but it's negative, so we're supposed to write negative. So we're gonna say negative, oh I'm sorry, this is supposed to be 3, and then this is supposed to be 4, and then this is supposed to be sine of 60 degrees. And then we have that other one. Remember, let me go back and show you so that you don't make any mistake. So if you can check here, we have an force of 4, so which has an 8 magnitude, so which is in the plane in a direction of 30 degrees. So we are going to say the force 8 is going to be positive because this sign, remember, is 8 sine of 60 degrees. So we're gonna punch this on the calculator. So this is 3 sine of 45 degrees, and then minus into 4 sine 60 degrees, and then plus 8 sine of, is it 30 or oh, or remember, this is 30 degrees, it's 30 degrees, so 60 degrees, so no, sorry, it's 30 degrees this one. And then we're gonna have the magnitude of 2.657 Newton. Remember, here we have positive, and let's check for that other one. We have negative here. So if you can check our f of x on the negative, we remember this is going to be west. right? So let's go to the other one, which is going to be this one is talking about the vertical one. It's going to be north. So if you can take our Cartesian plane, this is north, this is east, this is west, and then this is south. So for the F was going to this side and then was also going this side. So it's going to be like this. I hope you guys understand. It's going to be like this. So F we have something like that. So remember we're supposed to also calculate the resultant force. So we're going to say the resultant force is equal to apply the Pythagoras, the f of x all square plus the f of y all square. This is a Pythagoras. Okay, so the r square is going to be f of x is going to be, remember we got negative 9 point, let me confirm. So we have negative 9.807 0.807 all square plus into 2.657 all square. So we're going to punch this on the calculator. It's negative 9.807 all square plus into 2.657 all square, which is going to give us 103.238, and then we square root that answer. We are going to get R being 10 Newton point 161 Newton. So we're supposed to find then the angle. So we're going to say theta is going to be tan of inverse. Remember, we have f, we're dealing with f of x and f of y. So the sum of the f of x and the sum of the f of y is going to be, f of x is going to be down, which is going to be negative 9.807, and then the one is going to be 2.657. And then when we try to punch down on the calculator, we're going to say the inverse of 2.657 divided by 9.807 all square is going to be 15.159 degrees. So remember, if you can check, I said our f of x was negative and then y was positive. So this is going to be, remember guys, it's going to be, so the direction is going to be the north of west. It's all about that. So it's all about that. So I think today we're gonna stop here. So just look out for the other videos and some episode. Remember guys, don't forget to like, follow and subscribe. So gonna see you on the next video. So if you also want to join our extra classes, we do have extra classes at Pretoria, Mamelodi West, at Zakotabo High School, and we also do online classes. If you also want to join our online classes, you can contact 079 487 2458. Thank you.